Hi, my name is Bryce Odom, and this is Lab 3, the magnetic field of a bar magnet. The purpose was to analyze the magnetic field of a bar magnet and then compare the observation with what the code says. These are just some observations. Basically, the moving it closer to the magnet caused the X component to change, and then moving it further from the bar magnet caused the X component to decrease and then closer increase. And so the position of this affected the X component. And then the fundamental principles under for this lab was the Biot-Savart law, and this is the part that we put into code because it's kind of hard to calculate this at any other distance except for on or off axis, because this part simplifies when it's on or off axis. And then this is the distance dependence formula for a bar magnet, and then this is the on axis, this is the off axis. The experimental procedure was we had to compensate for Earth, the magnetic field of Earth, so we aligned the phone so that the Y component was 0. Then we placed the bar magnet at the edge of a ruler that we had now aligned underneath, or like had in the same, it is basically parallel to the phone in its width. And then we had to find the magnetometer of the phone, which we'll talk about, and then we had to take measurements at different locations on and off axis. And the system was the observation location, like each one that we did, and the surroundings were the magnet. This is how we found where the magnetometer was in the phone, and basically we had the phone aligned like this, and we moved it up and down until the X component was at its greatest and the Y component was at its lowest. And then this way was when the Y component was at its, and moved it up and down. And the phone was like this direction, and we moved it up and down to find when the X component was at its lowest and the Y component was at its greatest, to find where that, and we marked it with tape like this. That's what these yellow lines are. And then we already knew what that was, so we had to use that, where that magnetometer was, as our like marker. And so we went through, like, this is what this part is right here. We found the not the net, but the magnitude of the magnetic field in the X direction at each of these distances right here. So 20, we found the distance at those magnetic, like those magnetic field numbers in Teslas. So 20 Teslas, microteslas, 120, 170, and 220. And we found the distances at those. And also 70. And then we did a similar procedure for the perpendicular one, but this time, obviously, we weren't on axis, we were perpendicular, and we formed a 45-degree angle whenever we moved it up. And then these are the calculations. So we took the distance dependence formula right here and set it equal to this formula and rearranged to solve from U. And so we got 7.39 amperes squared. And then this formula right here, each of these correspond to that. And then we took, as you can see, the ln, we took the e to that number right here, found that. And then n was this, and we put all those in this formula right here. But this is where that came from. So this is the on-axis data, this is the off-axis data, and the on-axis data was plotted on this chart right here, and it gave us this formula. This is the coding. This part talks about the magnet, setting that up. This is the function of the magnetic, for the magnetic field, for calculating it. And then these are the observation locations, all these vectors right here. These are just creating the arrows for each of those observation locations. And then this is for the 45-degree angle one. And then these are the arrows that were generated. And then it also printed out what the 45-degree magnetic field should be. And this is what we got in the data that we did experimentally, and then this is what GlowScript gave. And then some sources of error could be the external magnetic fields that were affecting the system. There were other ones. We didn't calibrate correctly, and also there were measurement errors. And then for this first question, if you didn't account for the Earth's magnetic field, it would increase or decrease your true value because you weren't accounting for it, so it would make it either lower or higher. And then also, if you were to stick two identical magnets together, what would happen? Well, if you stick two identical magnets together end to end, that doubles the field, so your measurements would also double. And that is all. Thank you.